Hello everyone and welcome to another video. In this video we're moving on to talk about U-substitution, which is one technique to evaluate integrals. So remember, where were we, right? Where we left off was that the fundamental theorem of calculus gave us a method to evaluate integrals without using areas. Right, so basically what the fundamental theorem of calculus said was that we can use antiderivative formulas. Basically what it said is that the integral is the opposite of the derivative, so we can use antiderivative formulas to calculate integrals. So basically it said that integrals, right, we can evaluate just like we would an antiderivative. However, not every function meets the notation of an antiderivative formula. So remember, like in calculus 1, if you had composite functions, right, which remember that's when one function is plugged into another. If you had a composite function, you needed the chain rule, right? If you had a product of two functions, then you would need the product rule. And if you had a quotient of two functions, you would need the quotient rule. And so in calculus 2, the same thing applies, where it's like if your function is more complicated, then you can't just simply use an antiderivative formula. So what we're going to see is if we have some sort of composite slash product of two functions, right, we're going to need what we call U-substitution. And U-substitution is not just a simple formula like the chain rule, but it's a process that will follow when we have more complex functions that don't meet the antiderivative formulas. So remember that the antiderivative formulas are these formulas here, and what I mean by they don't meet the notation is if your function is not exactly, your integrand is not exactly of these forms, right? Like just a simple x there, right? If instead it was sine of x squared or something of that nature, anything different than just these simple x's in these functions, right? Then you need to be more careful when you do the integral. So these integration formulas only apply when we have functions of the form exactly like they are written on the left parts of these formulas here. Okay. So what's U-substitution? Suppose that f of x and g of x, what is that? Are functions, and let g prime of x be the derivative of g of x, and let capital F of x be the antiderivative of f of x. Then if you're given an integral of this form, right, so basically if you have some function f, right, with another function, g of x plugged in, remember we're talking about composition of functions, multiplied by the derivative of g, right? So what does this remind you of? What is this here? Right, this is exactly the chain rule for some function f of g of x, right? Similar to that. This really reminds us of the chain rule. So U-substitution, even though the chain rule really would be f prime here, right? But this format of a function, it reminds us of a chain rule. So we're basically doing the opposite of a chain rule. So what we do, right? So what U-substitution calls us to do is basically we have to let U equal g of x. So whatever function g of x is, you're going to replace it with u, right? So this becomes the integral of f of u, right? And then if we do the derivative of u, right? So remember that d dx, that is a notation for the derivative. So then we say, let's take the derivative of u, right? And we know that's equal to whatever the derivative of g is, right? Because remember, we're letting u be g of x. So if we take the derivative of u, that's the derivative of g, right? And then what I'm going to do is I'm just going to multiply, let me move this down, both sides of this equation by dx, right, the denominator. And right, what's left is du equals g prime of x dx, right? So now what I have to do in my equation, I'm going to replace g of x with u, and then I'm going to go ahead and replace g prime of x dx, right, by du, right? Because this, right, this whole thing, let me use blue, this whole thing is this whole thing here, so it could be replaced with du, right? So I'm going to do that. So this becomes f of u du. And remember, when I first introduced integrals, we said we can integrate with respect to any variable, right, as long as it matches. So now, instead of integrating with respect to x, right, we integrate with respect to u, right? So what that means is that we're treating u as the variable. And basically what this did was that by replacing g of x with u and g prime of x dx with du, we are simplifying the integrand, which remember is the function we're trying to find the integral of, to be able to use one of the antiderivative formulas directly. Okay, so where are we, right? Remember, we're right here. So let's bring that down. So right now we need to figure out how to integrate f of u du, but remember we said that, right, we said that capital F of x is the antiderivative of f of x. So whatever the antiderivative of f of u is, right, is f capital F, right? We said capital F is the antiderivative of lowercase f. And then since we don't have bounds, remember, if you don't have numbers here, you always need to add that plus c, right? Because that's an indefinite integral. And then, so we integrated with respect to u, right? So we can, when we do an example, we'll use an actual antiderivative formula. And then at the end, we're going to plug back in u. So this is going to become capital F of, remember, u is equal to g of x plus c. So this is what U-substitution is and the whole idea behind it. And I'll write these steps out more concisely, but I'm going to first do an example in order to hopefully get all of this to make more sense. Okay, so the example we're going to do is U-substitution or substitution equivalently, to find the antiderivative of 6x times 3x squared plus 4 to the 4th power, right? So if we look at our integrand, which remember is the function that we're trying to integrate or find the antiderivative of, this function does not match any of the functions here, right? None of these have that same formatting as that other function that we just wrote. So we know we need to do U-substitution. And another technique is, how do we decide what to make u? Like, well, if you notice, when we did the statement, u, right, we made it equal g of x, and g of x was inside some other function, right? So whatever you make u, it has to be inside of another function, and on top of that, right, remember, the derivative of u, which was g prime, since the derivative of u, which is g prime, is g prime of x, right? So basically when you're choosing u, so to choose u, right, u must be inside of another function, and that must be multiplied by du, which is the derivative of dx, right? So if I wanted to choose my u for this example, right, would 6x be a good choice? Right, 6x would not be a good choice because that's not plugged into any other function. My other option would be, right, this function, right, has on the outside, so I'm going to use I'll use O of x to denote that it's the outside function, right, is x4, and then I of x for the inside function is 3x squared plus 4. So which do I choose? Remember, you want to choose the inside function. So this is going to be our u, and then if we notice the derivative of that, what is it, right? Derivative, you bring down the 2, multiply it by 3, that's 6x, and then the 4 goes to 0. So we see that we have the derivative of u also present. So we know that this is a good choice for our u. So let's do it like that. So what we're going to do is let u equal 3x squared plus 4, right? Then we take the derivative of u, and that's going to be 6x dx. Right, so then I plug that in, and I end up with, right, so if we rewrite this and we move the 6x over, then we know this whole thing becomes du, right? So this then becomes u is raised to the 4th power, and then 6x dx all becomes du, right? So you can see how we now simplify the integral, and now remember, when you plug in u and you plug in du, now we have to integrate with respect to u. And when I write WIT, that's short for with respect to. And so when you do u substitution, right, you should always end up, when you plug in your u, when you plug in u and du, none of the old variable, which in this case, right, the variable originally of our equation was x, right, so x should be present. So if it is, if you ever like plug in your u and du and you still have x's left over, that means you chose a wrong u. So if you do, you need to revise your choice.
You'll need to unlock your iPhone first.
For u. Okay, but we know we're good because this equation, when I plug in my u and du, now it's all in u. And guess what? U to the 4th du, we're able to use the power rule, right? So remember the power rule for antiderivatives. You add 1 to the exponent and you divide by that new exponent. And then again, we don't have bounds, right? This is an indefinite integral, so we have our plus c here. And then remember, the last step that I talked about was to plug back in u. And remember, the du, that goes away when you do the integral, right? Like, this is only here to tell you what you should integrate with respect to. So once you integrate, this is, right, it's gone. The du's gone. Okay, so then I plug back in u. What was my u? My u, I said, was, oh, it's right here. 3x squared plus 4, and that's all raised to the 5th power, divided by 5 plus c. So that is the answer to our original indefinite integral question. Okay. So let's go over all of the steps that we just did. So steps, thinking ahead there, steps for integrating with substitution, right? So the first step is going to be look at the integrand, which remember the integrand is the function we are taking the integral of and choose and choose a g of x within the integrand to set equal to u. Right, so to summarize that, choose u, right? And then the key is that you select a g of x that's plugged into some other function f of x, and that the derivative of g prime, is present in the integrand. Right, so basically, like, you want to figure out how your integrand fits this left-sided notation of the U-substitution definition. Oop, I forgot my g prime. Right, so you want to choose a g prime where you see, choose a g where you see it's inside of f, and also that g prime is in your integrand. And then 2, you want to plug in / substitute in your u, which is equal to g of x, and your du, which is equal to g prime of x dx, into the integral. And then once you do that, right, a key there is that you should no longer see any of the old variable, right? That is only u's should be present. Right, so part 3, step 3, is going to be integrate. Right, and what does that mean? That means use an antiderivative formula with respect to u. So remember, that means that u's are variable. Right, so the key here, right, if the integral cannot be easily evaluated, right, or calculated using an antiderivative formula, we should go back and select a different u and try again. So the whole point, remember, of U-substitution is that we're simplifying the integral to be able to use an antiderivative formula. So the last step is going to be to plug back, right? So after you do the integral, once you do the antiderivative formula with respect to u, you plug back in u equals g of x and write the result in terms of x, right? Because we were asked a problem in terms of x, so we need to give a solution also in terms of x. Okay, I'll do another video doing some more examples.